Have you ever heard of Project Icarus? If you look it up, you might find this declassified story about a lone astronaut on a secret mission to Titan. But then, if you search again, you'll find a Cold War plan to nuke an asteroid. And if you search a third time, you find a modern blueprint for an interstellar starship. So, which one is it? Okay, let's dive into this.
It's pretty wild, right? The name Project Icarus seems to point to three totally different, totally contradictory stories. One is this dramatic tale of survival. Another is a doomsday defense plan straight out of the Apollo era. And the third is this far-out dream of reaching the stars. And the most fascinating part? They're all, in their own way, correct.
So here's the puzzle, all laid out. We've got a classified mission from the 70s, a declassified study from the 60s, and an ongoing research project from our own time. And each one has a wildly different goal: manned exploration, planetary defense, and interstellar travel. It's time to unpack these case files, one by one, to figure out what's really going on here.
Okay, first up is the most dramatic and, let's be honest, the most cinematic of the three. This is the story of Captain Rick Pierce, a United States Air Force pilot on a secret one-way trip to Saturn's moon, Titan. This isn't just some dusty old plan. It's a full-on narrative, pieced together from supposedly declassified audio logs.
Just listen to this transmission from Captain Pierce. It's June 23, 1977, only one day after his launch. He had just smashed the record for the farthest manned spaceflight, a record held by Apollo 13. You could just feel the triumph in his voice. He was on an 8-year one-way journey to explore a new world. I mean, he was the definition of a pioneer.
But fast forward to day 174, and that initial optimism is already starting to crack. Pierce discovers a leak. And it's not in his oxygen, thank God, but in his food supply, this nutrient paste that's supposed to last him 8 years. It's actually contaminating his air filters. It sounds like a small problem, right? But out there, in the total isolation of deep space, it's the first domino to fall in a long, catastrophic chain of failures.
And from there, the mission just spirals into one crisis after another. By day 290, the psychological toll is so bad that Pierce actually fakes an equipment failure just so he can do a spacewalk and convince himself that the mission is even real. Then things get physical. A collision with an asteroid cluster damages a vital solar panel. By day 841, he's hallucinated a pilot friend who had died years earlier. And then on day 1167, we're talking over 3 years in, he performs this incredibly dangerous EVA that finally locates the food leak, but at a massive cost to his remaining oxygen supply.
So let's get this straight. The story of Captain Pierce is exactly that, a story. It's a really compelling piece of fiction, but it borrows its name from two very real projects that are just as ambitious and, honestly, in their own way, just as dramatic. So let's take a look at the first of these real-world projects.
All right, for a second case file, we're jumping in the time machine and heading back to 1967, the absolute height of the space race. This wasn't a secret mission, but an academic exercise given to a group of graduate students at MIT. And their assignment? Oh, just to save the world from a cataclysmic asteroid impact? No big deal.
So the problem was laid out by Professor Paul Sandorf. He tells his class to imagine that this real-life asteroid, 1566 Icarus, is on a direct collision course with Earth, and they have just 15 months to come up with a workable solution. I mean, talk about a high-pressure final project.
And the stakes here were, well, astronomical. An impact from a rock this size would release the energy of 500,000 megatons of TNT. Now, to put that into perspective for you, that's more than 33,000 times the power of the bomb that leveled Hiroshima. It would be a true extinction-level event.
The students, they got right to work on this like true engineers. First, they figured out what wouldn't work. Blowing it to smithereens? Nope, would require a bomb that just didn't exist. Gently pushing it off course over time? Not enough time for that. So they landed on a plan, a fast intercept. The idea was to fly out to meet the asteroid, detonate a nuke nearby, and use that blast to just nudge it off course. And for the hardware, they chose the biggest tool in the toolbox, the mighty Saturn V rocket.
And their final plan was, wow, just incredibly audacious. They proposed using 6 Saturn V rockets, launched in rapid succession, each one carrying a 100-megaton nuclear bomb. But here's the kicker. The most powerful bomb in the U.S. arsenal at the time was only 25 megatons. Sure, the Soviets had a bigger one, but it was way too heavy to launch. So the students' plan was brilliant, but it relied on a piece of technology that was just out of reach.
Okay, on to our third and final file. This one brings us right into the 21st century, with a Project Icarus that's not about one astronaut or saving the planet, but about taking humanity's first real, concrete steps toward traveling between the stars.
You see, this Project Icarus, which kicked off in 2009, is the direct sequel to a legendary study from the 70s called Project Daedalus. Daedalus was really the first serious engineering blueprint that proved reaching another star wasn't just science fiction. So the goal of this new Icarus was to take that 35-year-old design and see if today's technology could make it actually credible.
So how did they update the original plan? Well, Project Daedalus was designed for a super-fast 50-year flyby of another star, basically just a drive-by shooting of data. Project Icarus added a huge new challenge. It needed to be able to slow down and actually enter orbit around the target star. Now, to make that possible, they had to relax the timeline to under 100 years. This is a monumental engineering problem. The ship basically has to perform 2 launches, one from our solar system and then another one in reverse when it gets to its destination.
So let's be clear, nobody's building this thing tomorrow. It's a theoretical engineering study. Its goals are to design a credible fusion-powered probe, at least on paper, to try and solve massive challenges like deceleration, and maybe most importantly, to inspire a new generation to think about these enormous problems. It's all about proving that it can be done.
So we have a fictional survival story, a doomsday defense plan, and a blueprint for a starship. 3 completely different ideas, all sharing one name. Which brings us to the big question. Why? What on earth connects these 3 projects? The answer, of course, lies in Greek mythology. Icarus was the son of Daedalus, the master inventor. Using these amazing wings made of feathers and wax, Icarus escaped from a prison just by flying. But in all the excitement, he flew too high, way too close to the sun. The wax in his wings melted, and he fell from the sky into the sea. It's the ultimate cautionary tale about ambition.
And that is the connection. That's the key. All 3 of these projects embody the spirit of Icarus. They represent humanity's greatest ambition, to survive, to explore, to reach for the heavens. They are all unbelievably audacious, pushing the absolute limits of technology. But the name is also a warning. It's a humble acknowledgement of the immense risk involved, a recognition that when you aim that high, the fall can be absolutely catastrophic. So, from a lone astronaut's desperate journey, to a plan to save the world, to a blueprint for reaching the stars, the name Icarus represents both our boldest dreams and our greatest fears. And it leaves us with a final thought. In our own time, with huge challenges like climate change, artificial intelligence, or colonizing Mars, what modern ambition, with all its incredible promise and all its terrifying peril, truly deserves the name Icarus?